Hi, my name is Srijit Mohan. I've been working as a software testing trainer for the past 8 years. Apart from that, I have conducted several seminars and corporate trainings in the IT industry. Today, I'm going to start with your software testing fundamental concepts. And in this topic, today I'm going to cover about what exactly software testing is and why it is important in the industry to do the software testing before delivering the software to the customer. Then what are the different types of process that is such as different methods, different levels, and what are different types of defects which have been found during the software testing process. So let's start with the first topic, what is exactly software testing is. Now, what is exactly happening in the industry? Whenever we are developing a software, the customer is expecting that the software should be working as they are expecting from the customer, in the customer's point of view. So, in the industry right now, as per the record, there are almost the cost of failure which has been happening related to the product is 3.312 billion dollars of failure cost has been happening in the industry, and half of the softwares which have been released in the market is still having 50 to 80% of defect in the software. So that shows that why testing is so much important in the delivery of a good quality of the software. So yeah, so what's the definition of software testing? Let's take the example, like when we talk about, apart from talking about the software testing, let's use the word term testing. Now, whenever, if as a common man, if you go to any grocery shop or if you're going to buy any kind of product, like for example a pen from a stationery shop, we always, before buying it, we check that whether the pen is working or not. Roughly we write in somewhere in a blank page and we check that whether the product is being properly in the working condition or not. Same way, whenever customer is uh, ex, accepting the software from the company, they also expect that the software should be in the proper working condition. So for that purpose, we the IT industry, what are they going to do? They're going to test the software on a customer's perspective. So here the testers come into the picture where they do the testing and a customer's point of view, and they are going to check that whether the software is been developed as per the customer's expectation or not. So here, as per the definition, the process of comparing between the expected result with the actual result is called as software testing. Now, what is called expected result? So, expected result such as like what kind of expectation the customer is expecting, what the customer's need is called as the expectation, and what exactly the software has been delivering is called as actual result. So, if these two behaviors, if these two results are perfectly matching, that means your software has been developed as they need. But if this mismatches, that means there is a problem, there is a mistake in the software. And that's what our responsibility is, to identify the mistakes, identify the defects from the software. So the process of comparing between the expected result along with the actual result is called as software testing. Now, apart from that, there is two more constraints which we need to check while doing the software testing is completeness and the correctness. Whether the software is complete or not. Now, what does mean by completeness? Now, if the customer has 10 requirements, now if all the 10 requirements has been fulfilled, is been implemented in the software, then we can say that yes, it is complete. And what is correctness? It means whether all the 10 requirements are properly working or not. That is called as correctness. So that means completeness and correctness. Even those two parameters, we need to check that whether your software has been completed or is been working perfectly fine or not. So if it is correct and if it is complete, then we can proudly say that our software has a good quality software. We can deliver a good quality software. So by definition, we can say that software testing is not only just an execution process, it also checks the completeness and the correctness of software so that we can determine that we can deliver a good quality software. That's called software testing is all about. Now let's talk about the different kind of goal and the purpose of testing. Here we can see business alignment. The first point here, it means that are we delivering the software as the customer need? Is it everything properly working? Is any kind of fault in the software or not? Business point of view, I'm talking about that whether the customer's expectation has been fulfilled or not. Secondly, quality assurance. Now, performance wise, in instance, whether the software is performing as expected or not within a particular period of time. Like for example, if I try to log in on a particular website, I'm expecting the login should happen within seconds, right? I give the username, I provide the password, and I will click on the login button. It should happen within a nanosecond. It should log in and it should open the home page. So performance wise, each software is performing very well. Security wise, even reliability wise, all this properly working or not. That's the quality assurance part. And the last, defect detection. Okay, so that is how much defects we can detect from the software. It's a tester's responsibility that we have to detect as many as defect from the software. So, these are the key important purpose of doing the testings. That are we fulfilling the business needs? Are we providing the software as expected or not? And are we providing the software with less number of defects? Now, there is one term in testing that we cannot provide a software which is, we can say, defect-free software. There is no such software in this world which is defect-free. We can always guarantee a customer that we can provide a defect-less software. So that means during testing is a process we can find as many as possible as defect from the software and clear it out, and we can deliver a defect-less software to the customer. So these are the key important purpose of doing the testing. Let's move on to the next topic. Types of defects which have been found during the software testing process. First of all, functional defects. Now, what is called functional defects? First, understand what is the meaning of word functionality. The functionality means, when you talk about the functionality of the software, it means features. Features, for example, let's take the example of WhatsApp. This is an application, right? In WhatsApp, what a customer can perform, what a customer can do is called as functionality or features. Like for example, a user can chat with any kind of sender. A user can send a text message, a user can send any kind of video or any kind of audio message. He can send a location, he can mute, he can block, he can add a new contact. That means whatever the customers can do, what behavior the software performs is called as functional. And if there is any kind of defect which comes based on this functionality, that is called as functional error, or you can say functional defects, whether your software having any kind of such functional defects or not. Next, performance defect. As I said earlier, performance means how quick response you're getting from your software. Performance and functionality is two different things. Functionality means behavior. Performance means how it always gives the answer of how well your software is responding to any kind of request. How well you are getting the response, how fast you are getting the response. That is called as the performance. And if you have any kind of defect or mistakes or error related to this characteristics, it is called as performance error. Next, security. Security is a big term actually in the testing, because whenever you're developing software nowadays, there are lots of hackers and intruders who are trying to hack the customers personal data. And there are lots of different way through which people, the wrong people can get access to the wrong data. So for that purpose, whenever you're developing a software, we have to make sure the software has good security level is been built up in the software. For that purpose, nowadays, like we have OTP kind of concept through which we can log in into a device, not just with the username and password, along with the OTP which has been provided. Because OTP is just is a private message or private four-digit number which has been given to a particular user. Apart from that, we can have another security measurement, like giving a email or giving a link, passing a link to your email, private email accounts, or else there's a different kind of security measures. So are we are building with a developed software with such built-in security measurements or not? And if there is no such kind of big security measurements, and there is kind of loopholes through which a hacker or a virus or threats can attack, through the software, intruding to the software, and a malicious user can get unauthorized access in the software. And if such kind of vulnerabilities are available, is there in the software, that is called as the security vulnerabilities. And the last one, usability problem. The usability in the sense how user friendly your software is, how well your software are you able to understand, a customer is able to understand the software. Now, for example, If you want to chat on a WhatsApp application, it's quite simple. Open the WhatsApp application, just enter the number of that person, and you can start chatting with that person. But what if there are 10 different steps to start with chatting with your friend? It's a very lengthy procedure to start with chatting of, for a different person. It makes quite a difficult situation for a person who are not from the IT background, who are like from the rural area, the people who are not well educated. They are not able to understand exactly how to use the software. The usability means how easy, how user friendly the software is. So if the software is too difficult to understand, if it's not able we are not able to understand how to use the software, that's called usability issue. So these are the different kind of defects which have been found during the software testing. Major kind of defects which have been found. Apart from that, there are other defects as well. We'll go dive into it as the chapters, as the models we go ahead. We'll dive into the new kinds of defects, process and all. But these are the different four different major kind of defects which have been found during the software testing. Yeah, key terms of software testing. As this is just an introduction topic, that's why I'm going to cover up different key terms like defect. What is called defect? As I said, the definition about software testing. What is the definition of software testing? The process of comparison between the expected result with the actual result is called as software testing, right? We are comparing our two different behaviors, and while just doing this comparison, if these two behaviors are not matching, that moment, that concept is called as defect. So what's the definition of defect then? The difference or the variance between the expected and the actual behavior of the software is called as defect. So if this behavior doesn't matches, that moment and that term is called as the defect. Defect can be known in different words. It is also called as bug. Some people call it as bug, especially developers. Actually, they call it as bug, and some people call it as failures. Mostly client, they refer to use the term failure or fault, then incident, then mistakes, problems, errors. These are the different synonyms of the word defect. Next key term, test cases. Test cases is very crucial part, very important document in a tester's career, because without test cases, the testers can't do the testing. So test case document is very important document. It has been created, mostly created by the testers itself, and for that purpose they have to learn about how the test case has been prepared. There are certain procedures to understand how to creating the test case and all. Majorly test cases contain the steps which have been followed for doing the testing process. Along with the steps, we have expected result and the actual result column through which we can compare these two results, and the input, what kind of input we are going to provide while doing the testing. So these are the four important major columns which the test cases contain. And like I said, there are different procedures and for uh, procedures and steps which have been followed to develop test cases. In the upcoming chapters, we're going to learn about how to create the test cases. Next key term, test coverage. Now, when you talk about the coverage means how much area of the software has been covered. That's called the coverage. Now, if your software has 10 different models in the sense like login, then registration, then search, then payment. So these are called models. And in every model, there are sub models where we have n number of code which is written for every each features which have been included in the sub model. For every features, there are code which has been provided. And if you're covering all the code, then we can say that there is 100% coverage. So how much portion, how much part of the code is been covered, how much part of the software is been covered with the testing is called as the test coverage. Another key term. Then regression is also very important type of testing in the tester's career, because uh, whenever there's a change in the software, yes, you have to perform the regression testing. Regression testing is a testing through which we can identify that due to any kind of changes which is happening in the software, that changes is been producing any new defect or not, the area where it was working fine. So regression is a process through which we can identify the defects which may or may not be there, but to identify that whether due to the changes, is there any kind of side effect or impact on the unchanged part. So that's another type of testing. These are the four important key terms in the testing. In upcoming chapters, we're going to learn about in depth about all these four key topics. Let's move on to the next one. Yeah, test levels. Now, testing is is a process, right? So the process happens in four different steps, or you can say in four different levels. The first and initial level of software testing is unit testing. The testing of a software always starts from the unit level. Now, what is called unit? Unit in the sense a small piece of code which is written for a single feature or single functionality is called as one unit. For this kind of behavior, for happening to happen a login, there is a code written which is written behind of that software. So executing that code only for that login functionality. Obviously, there are hundreds of code which has been written for each and every features, but for the code which is written only for login functionality, we are executing that code and we're checking that whether that code is properly working or not. That is called as unit testing. Same way, for every features which has been there in your software, for each and every features, there will be each code which has been written. Individually, we execute each and every code and we check that each and every code is properly working or not. That is called as unit testing. So that means the testing of a software always starts with the code level. That's your base. You can say it's like a pyramid, and unit testing is the base of your software testing process. If your code is properly working fine, if your base is strong, then the pyramid can stand properly with a strong base, right? If the base is weak, obviously the pyramid is going to collapse. So your base of your software is code. If your code is working fine, obviously it is a stronger base. Once your code is properly working, then we move on to the next level, that is integration testing. In integration testing, we focus on the interfaces of the software. Now, interfaces means the communication link between two different models. Like, for example, when you upload a photo in Instagram, at that moment itself, it prompts a message that do you want to upload this photo, same photo, in Facebook? Now, Instagram is a different app. Facebook is a different app. They both are different softwares. But there is a link, right? There is a communication link which has been connected to this software, to both the software. Why? Because whenever you're uploading a photo in Instagram, and if we give the permission to upload same in the Facebook, the same photo is being transferred. The data is been transferred to the Facebook, and the same photo has been uploaded in the Facebook app also. So that data transfer between two different systems. Or another example, in WhatsApp itself, when you make a call, audio call to any kind of any person, you talk with that person for 1 hour or 2 hours or whatever it is. So what happens when you done with the call? The details of each and every call that which you had done with that person will be transferred to the call model. There are four different models in WhatsApp. That, like, you have chat model, you have update community update model, then you have call model, right? You have payment models. So there are different models in the software. So from one model to another model, your data is getting transferred. Okay, that transferring link is being checked that whether that interface is properly working or not. That is called as integration testing. So that's your next level after the code is, yes, of course, before starting with the integration, we have to make sure that all the code is properly working or not. If the code is not working, we can't start with integration testing. So once the code is properly working, then we go for the integration. And integration, and like I said, we are going to focus majorly on this interfaces section. So in your software, wherever this interfaces, this communication link has been provided, we focus on that and we do the testing for that particular area. Once all the interfaces in your software is been covered, is been tested properly, and is properly working, then we move on to the next level, that is the system level. Now, system level is the actual level where we the testers, actually we the manual testers and automation testers, come into the picture. Yes, of course, unit testing is also testing part, but obviously it is not done by the testers, it is done by developers. Same like integration testing. It is done by the people who are trained in the integration in this interfaces level only. You can say API testing and all. This comes under this interfaces level where we have to check the interfaces between the so the people who are trained in that area focus on the integration testing. In the system testing level, the third level of the testing, the actual testers come into the picture. The manual testers and the automation testers come into the picture. Here, the testers are going to understand the entire in and out of the software. They start writing the test cases, test scenario, test cases, test procedures, test suite. They what are the documents, what type of documents they need. They develop all such documents and then start doing the execution of the test cases and identify the defects from the software. The defects may be related to functional or non-functional. So A to end to end. That's why system testing level is called as end-to-end testing, right? Because we cover the entire 100% area of the software, and we make sure that whether your software is working properly or not. Because that's the reason system testing is the actual level where we the focus, the scope of testing of that particular level is that whether we can release the software to the client side or not. That's the scope of the system testing level. So once we completed with the system testing level, when all the major and minor and regression, retesting, all this kind of process been done, then we move on to the final and the last level of testing, that is acceptance level. As the name itself gives you the idea about like who's going to be the tester in this level. Yes, of course, it is customer. In acceptance testing level, we call the customer to the production environment and we ask them to do the testing of the software in the presence of the testers and developers, right? So there are two different types in acceptance testing: alpha testing and beta testing. So the testing which happens in the production environment, where in the presence of testers and developers, the client or the actual user or the actual customer representative may be doing the testing, and they are going to check that whether the software is working fine or not as per their expectation. So if they agree with that, then alpha testing is completed. Then we move on to the next part of the acceptance level, that is beta testing, which happens in the live environment. So there are two different testing which happens in acceptance. One which happens in the production environment and one which happens in the live environment. And in the live environment, it's also if everything is working fine, then we launch. Then we go on to the installation, the deployment process of the software. So acceptance level is done by the customers or the actual end user of the software. So these are the four different levels of software testing, which happens for every software which has been developed in the industry. Okay, so let's call to the summary of this topic 1.1. So exactly what is going to what we have learned here in this topic 1.1, what is exactly software testing is an essential delivery reliable and a functional software. It covers different types of defects and validates both functionally and the quality of the software. The key terms of the software testing is test cases, regression testing, then functional different types of defects we can identify from the software: functional defects, performance related defect, usability defect. So, and what are the different levels of software testing? So these are the few points which I have covered in this entire model. Let's see what we can learn in the next model 1.2.
To know more about Itvedant, visit our website